It's sort of the marketing idea would be sort of like cell phones are doing for long distance, where you could just sign up for one fee and all of the electricity you could use each month would be placed under that. Imagine a world where you have so much electricity that you're trying to use more.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues. Hello and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. Currently, recycling of nuclear fuel in what are called fast breeder reactors is not being done, and I think it is illegal in the United States. And research in that direction was shut down by Jimmy Carter's administration in the anti-nuclear movement of the 70s. Legislation preventing nuclear fuel recycling has a negative effect on the cost of nuclear fuel and has allowed many opponents to claim that the cost of nuclear power will skyrocket within 100 years due to shortages of known uranium deposits. It is possible that this single policy effectively sidelined nuclear in favor of coal for the ensuing 50 years. Now, the justification for policies like this are to prevent proliferation of nuclear weapons to other countries. The U.S. wanted to keep them all for themselves and their small clique, and they didn't want to spread enriched nuclear fuel around the world. Nowadays, I don't know if that justification still holds water. Just about any country who wants nuclear weapons has got them now through other means, and not considering recycling of nuclear fuels is now resulting in something like 8 million deaths a year through fossil fuel burning and air pollution. Mr. Thomas Dolan has an aviation degree from Embry-Riddle Aeronautical University and is an FAA Commercially instrument-rated pilot. Mr. Dolan joined Nassau County Police Department in 1986 and accumulated over 25 years' experience in law enforcement. Mr. Dolan formed and was the CEO of Homeland Security, Aviation, and Maritime Services, Inc. in 2002 with a group of technical experts addressing identification and measurement of radiation sources in response to the needs of the emergency response community. Tom is a current member of the American Nuclear Society. Tom, welcome to The Rational View.
Thank you. Glad to be here.
Stephen Curtis holds a master's degree in health physics and a Bachelor of Science in electrical engineering, both from UNLV. He worked on the Nuclear Emergency Support Team and Radiation Consequence Management missions for Department of Energy, National Nuclear Security Administration for 13 years, and was project manager in charge of the aerial measuring system. Mr. Curtis held battalion, staff, and company commander positions as an officer in the Army and Nevada National Guard. He has supported National Security Technologies LLC as a consultant in support of the Nevada test site. He's worked with Science Applications International Corporation on several domestic nuclear detection office architecture projects. Steve is a current member and past president of the American Nuclear Society Nevada section. Steve, welcome to The Rational View.
Thank you, Al. Glad to be here.
So together, you've created an organization called Waste to Energy Now. How did you guys decide to start this venture?
Well, we actually were working with another group, the Climate Coalition, an organization to keep and address different. Right now, they're very actively with Illinois trying to keep different power plants from closing. They were also fighting for Indian Point and Diablo Canyon. But prior to this, Steve and I have been working together since 2019 to try and recycle used nuclear fuel through whatever best possible ways to do that in the United States. This way we could leverage the over $45 billion nuclear waste fund that Congress currently holds that has to be used specifically for nuclear waste in the United States. And there's over 100 sites throughout the United States that have used nuclear fuel. But what most people don't realize is that there's still 97% uranium still available for production of power.
So the current nuclear generators, nuclear reactors that we use only extract 3% of the energy from the uranium fuel that they have, and the other 97% is just waiting there to be used. Is that what you're saying?
Yeah, that's correct. Steve is the technical director. He could inform you a little bit more on that. Go for it, Steve.
The basic idea is that we are going to try to entice a governor of a state to accept used nuclear fuel. That's really the crux of the problem right now, is that the United States government intends to bury this fuel. So we think that's a travesty. They've tried for 40 years to bury it, and still they have no solution to it. So we're just trying a little different approach. And if a governor can agree to accept used nuclear fuel, they can develop a business that's easily $10 billion a year in clean energy. And there's enough of this clean energy just sitting in stockpiles right now at reactor sites to power the United States for 200 years. And we really only need about 100 years of that until we get to our next generation of power systems, which are probably fusion or something called space-based power. But right now, we are basically, the public is against nuclear for what they've heard on the radio and TV for now 40 years. And that's sort of a travesty to us, because this is a very compact energy source. It's not going to take square miles of property. It's not going to impose on people at all. And there is a huge benefit in having a base load power, which means it's on all the time, energy source. And a lot of these new reactors we're talking about don't need to be refueled for 7, sometimes as many as 30 years. So if you can use what you have in your stockpile to make energy, clean energy, it's 100% clean because the mining's already done. And that's our concept. So if we get a state, or we're open to any entity that wants to try this, we're willing to put it into force.
So before we talk about the politics behind this, which is probably the main thrust of your organization, let's maybe talk a little bit about the technologies required to do this recycling. Is this a new thing? Has it ever been done before? What are the technical steps that are taken to recycle this fuel and use it again?
There's just a number of different designs to do this already on the books. There are none ready yet for processing, but there have been to the prototype stage. Basic idea is that if you use something called a molten salt reactor, the used nuclear fuel simply dissolves into the molten salt, and you basically have what they call liquid fuel. So it's very safe, runs at atmospheric pressure, and basically the concept we're looking at, you just add some every so often when it runs low. Once you get it started, you can just keep adding the used nuclear fuel to it, dissolves in, and then you get the power out of it. And like I said, there's power for 200 years. There are other processes that use a solid fuel with the same concept. There's actually a sodium-cooled reactor that will work as well. But the basic concept is a fast reactor with fast neutrons will fission all of the uranium and all of the what they call higher level actinides that people worry about in used nuclear fuel. The result of this will be fission products, which are really, you need to sequester for 100 to 150 years. But there are also a lot of valuable minerals in there, rare earth minerals that we could mine later. So there's really no waste at all in any of this.
So you're basically just using spent nuclear fuel directly in these molten salt reactors? You don't have to process it at all?
That's correct. And there's about 83,000 tons sitting on the reactor sites right now, and there's more coming in. So it's a good time to start using it. If we do come up with a solution to the used nuclear problem, we can leverage that nuclear waste fund that's sitting in Congress that right now is about $45 billion.
Now, I know the molten salt reactors have been tested before. There have been research reactors built. I think there's some in other countries that are operating as test or pilot reactors. What's the scale, or what's the technology readiness of the molten salt reactors? Where are they in the process?
Okay, they have been through the prototype stage. So there was one operated in Idaho by Argonne National Laboratory for 30 years that ended in about 1994. And they proved the entire concept. It worked perfectly, no problems. In fact, they did have two failure modes, one like Fukushima, one like 3 Mile Island, and they put the reactor through those modes, no human interaction, and the reactors shut themselves down to a safe mode without any excess heat. So they're what they call intrinsically safe. And there's really no reason not to move forward with these, except that there's a reticence among the public to accept things that are nuclear.
Now, I've also heard it argued that for fast breeder reactors, you need to go through a fuel activation stage where you activate the fuel and then you can send it out again to other existing reactors. Is that a different pathway than what you're proposing?
You are capable of like making the solid fuel as well. So that's a process that's well understood. And indeed, you could ship the fuel to other places and use it in other reactors. But we think it's best to produce it in the place that you're using it. The ideal concept would be to put one of these reactors at each site where spent nuclear fuel already exists. And you could really have an abundance of energy. Imagine a world where you have so much electricity that you're trying to use more. And the implications for commercial applications, for hydrogen production, for desalinization of water, for making other chemicals, the processes that now use heat, you could use these reactors to produce that. And since you're trying to use up all the used nuclear fuel, you'd have, like I said, an abundance and an excess of electricity and actually encourage people to use more. That's our concept.
And so the resulting waste from the molten salt reactor still needs to be stored for some time, but not as long as the current generation of nuclear reactors, which have a much longer time to get back to background. Is that correct?
That's correct. We're looking at most 300 years, probably more like 100 to 150 years. And they're looking at something like 1 million years now for a repository, which is really a time period nobody understands. So I think that's why it hasn't proceeded forward. But we've already spent in the United States about $12 billion and have no solution yet. And no other state, not a single state in the union, will agree to accept used nuclear fuel. So we're at a standpoint. We think that we need to do something to try to really move that process forward.
So this then goes to the politics of the issue. I guess in the regulatory domain, it's been illegal to recycle used nuclear fuel in the U.S., I believe, since Jimmy Carter's administration. Is that the current status of things?
The history was that the industry itself was always going to reprocess this in the beginning when they started the nuclear reactors. Turns out that the reprocessing system is the simplest aspect of the entire fuel cycle. And so they didn't pay much of attention up front because they knew the easy technical solutions existed. When Jimmy Carter decided he didn't want to do that, then that kind of threw the whole system into a backlog. But at the same time, the United States government decided to take the responsibility for the used fuel onto themselves. And here we are. Few people know this, I think, but Ronald Reagan actually rescinded Jimmy Carter's restriction, and we are okay to recycle or reprocess used nuclear fuel. But by the time Reagan did that, they had moved too far down the uranium road, and they were mining uranium and enriching uranium for nuclear fuel, and decided that was the most cost-effective way to go for the time. So consequently, this stuff's been accumulating. The United States government was supposed to start taking this stuff in 1999, and here it is 22 years later, and they haven't taken a single molecule. And there is no plan in sight to go forward at all. There's a couple ideas for putting interim storage sites in Texas and New Mexico, but neither Texas or New Mexico has agreed to accept any used nuclear fuel. So those ideas are stymied until they can find a way to produce what they call a consent state. but there's no effort now to do anything to get a consent state outside of what we're doing. We're trying to offer a system where a state could have a huge economic benefit from this, where we could have an energy supply system, clean energy electricity, even for cars. There's plenty of energy for that, and have it at a price that's very affordable and very accessible for all humans, all people in the United States for sure. And we called it, it's sort of, the marketing idea would be sort of like cell phones are doing for a long distance, where you could just sign up for one fee and all of the electricity you could use each month would be placed under that. But it's hard to wrap your mind around a system where they're encouraging you to use more electricity because we're so restrictive on electricity now. We're sort of in a monopolistic system where single entities control your entire electric delivery system. And we all know that that's what happens. If you get a monopoly, you get higher prices. If you get competition, you get lower prices. We're trying to drive that part of it too, so people really do have a better system.
So you used the term consent state. What exactly does that entail? You need to get consent from a state. You need a referendum to pass to allow reprocessing of fuel in a state, or what do you need?
It's uncertain. I think you're referring to the consent state, the agreement state, where a state would agree to take used nuclear fuel. It's not certain how the legal implications of that are. In 2012, President Obama convened something called the Blue Ribbon Panel for dealing with this. And one of the recommendations was that we go out, we don't force this on a state, we negotiate with the state to try to get an agreement to take this stuff. But that's all it was. It was written on a document. Nobody tried that before. So there's a real tough sell now because people seem to be afraid of it. And no politician seems to want to touch the issue because of their perception of the public understanding of it. So part of it has to be an education process. We have to tell people that really they're turning down a super deal, a very impressive way to have a much better life. Because energy is the force of life. So the concept would be is how do we politically change that? And my experience has been that money's a powerful force. If you show benefits to people, they may open up their ears and overcome the risk that they perceive, especially if we can explain it to them.
Yeah, the anti-nuclear lobby is going to fight tooth and nail to stop any sort of final solution for nuclear waste, be it deep geological repositories or be it recycling, because that basically takes the ground out from under them. One of their three main things are Fukushima, Chernobyl, and waste, right?
It's a curious system. We all seem to want clean energy, and the way we're getting clean energy is the least dense energy source, the most intermittent energy source, and sort of the most difficult way to make it happen. And I frankly don't believe it's going to work in the long run to get all your energy from wind and solar. There's other renewables that are actually pollution-causing renewables, the biofuels and the burning wood and the burning garbage. So that just on the surface does not seem to be a long-term solution. So the idea is that if we can convince politicians that they're really working in the best interests of their people to push this idea forward, I think we'll have something there. But it's been so long that the general public has had their attitudes degraded on this area that we have a long way to go. I think it's important to work on politicians, but again, the idea is if you can offer them a benefit and a way to have a business out of this that really boosts their state in a high-tech area, then we may be able to convince somebody that it's a good idea. We've seen Wyoming has just accepted the reactor that Bill Gates has designed, the sodium reactor. His fuel is going to be thorium, so he's not thinking of used nuclear fuel, although he could use nuclear fuel in the future. So that's a step in the right direction. Here's a governor that has accepted nuclear as a viable energy source and pronounced that to the world. So we think there could be others, and we do not see any detriment in the actual technical and business case that we're trying to present. It's just a matter of getting people to see it and to move forward.
So I don't quite understand what the importance of the consent state is. If you're just taking your nuclear fuel and dropping it into a molten salt reactor on site, is it the fact that you can only have the molten salt reactors in these particular consent states, or what happens in the consent state? Go ahead, Tom.
The consent state, it's been 44 years stuck in the federal government that we need a consent state to bring nuclear waste into, just for storage. But at this point, we're trying to change it and saying it's no longer for storage, it's actually to recycle. Steve could probably talk a little better on this. However, recycling, we recycle everything, paper, plastic, you name it. Hey, this is a big thing that the anti-nuclear movement has always been on. Well, you don't know what to do with the nuclear waste. Well, we're showing you a way where you can get more energy out of waste, which is not waste any longer, and even the shorter-lived stuff, once it's been recycled, there's still palladium, rare earth metals in there. Stuff that we haven't used or weren't going to use back 40 years ago is now like, wow, it's got great stuff in here. We can mine it further and go into it. So basically, the consent is to say, yes, we'll accept used nuclear fuel, because right now no state wants it to store it there. But if we can show them a financial way other than just getting paid to keep it there, where they can produce electricity, make a profit, at the same time leverage the $45 billion to possibly put a carbon-free nuclear national laboratory and a research park where you're going to be the mecca, the first state that does it. It won't be only one state, but the first state that agrees to accept used nuclear fuel will make a big difference. And you will have to bring in other states, because all of a sudden you're going to see, let's say, for example, New Hampshire, they're going to be the first ones. You're going to see people like in other states like South Carolina. Hey, we want a part of that. Maybe Texas with Pantex. There's all sorts of different areas that could benefit by working with the first state, but you need the first state to actually break the mold, the old mold of let's find the biggest hole we can bury this stuff into.
It's certainly the value argument that you put forward, the fact that you're basically getting 30 times more energy out of the uranium than what the original mine has produced effectively in the first run through is definitely an attractive carrot to dangle. The questions that people are going to have are, why was this originally banned by the federal government? What was the reasoning behind banning this? It seems like recycling is a great thing. People love recycling. The
original concept, and I still kind of worry about today, is something called non-proliferation. They're worried about the plutonium from commercial reactors ending up in a clandestine state or the wrong hands to maybe make a bomb out of it. There's a couple things that are really kind of strange about that attitude. First of all, the plutonium from a commercial reactor used fuel is not conducive at all to making a bomb. There are just simply too many higher isotopes of plutonium in there to really make it useful and really make it optimal to produce a bomb. Supposedly you can, but nobody has, and nobody's even tried. Take North Korea, for example. They started from scratch, made bomb-grade plutonium, and made the bomb. They didn't go through the diverting the waste stream process because it just simply is not optimal. It's very difficult to do this. It's a process that takes a kind of a large scientific and industrial base to really reprocess spent nuclear fuel. So if they try it, it's a very visible process. It's kind of complicated. So the thought is, if you're a terrorist, or even if you're a nation state that's trying to develop a nuclear program, you're probably going to want to take the least expensive route that gives you the best shot. So it doesn't seem viable to me that they try that, but some people on the high levels of government were worried about it. And I think it's time to maybe revisit that piece of it a little bit. And like I said, when Reagan got in, he rescinded the restriction, so we're not under that restriction anymore. Although people still say they're afraid of the diversion from commercially used nuclear fuel. So that's the crux of the problem right now is that issue of non-proliferation. And I think we can easily overcome that with technology and just a very basic idea that terrorism is interested in the most expedient way to do things and the quickest way that they can get a result. And this certainly is not that approach. And nobody's tried it. There's lots of used nuclear fuel all around the world, and we're not sequestering all of it. So there's many options for that route to be taken. It never has been taken. So it just doesn't seem practical to me. So yeah. I agree with the fact that we can do it now, and maybe we should revisit the process.
One of the largest things that people in the United States really don't understand is France has been recycling used nuclear fuel for over 30, 40 years. They're actually taking fuel from Japan and recycling and sending back the used fuel, already a new fuel at that point. So, and they use an aqueous type of a way where it comes out mixed oxide fuel. They were doing this down in South Carolina. However, there are other methods, just like the fast reactor recycling, okay? That's almost like a direct route. You take it, the used fuel, throw it in the sodium, molten sodium, you're already producing electricity. There's an Argonne National Laboratory. They have a process there called a pyroprocessing. It's almost like electroplating. It's using high voltages, and it's extracting different metals or different items from it as they can reprocess, and it's actually good for different types of reactors. So there's many different ways to do this, many ways to skin a cat. And at this point, we need to get the state and the federal government to understand, hey, let's get this, going. We're falling way behind, even in nuclear energy in this country compared to China, Russia, other places. So we need to start making this happen sooner than later. So we're trying to do our bit here to get people to understand more about this. So there's many paths. Certainly the recycling hasn't been done in the past in a major way, and I can see the benefit and the potential advantages. So the key here is to address the public's reservations regarding nuclear fuel and to get past the hang-ups with transporting waste and what they see as the dangers of waste. The question in my mind, now I've talked to people who are very in the pro-nuclear camp are saying, this is the wrong way to go. We should be working on the deep geological repository because it's easier to get. It's the first step that gets this risk out of people's mind. Once we get the risk out of people's mind, then we can do with it what we will. But we need to get it into the deep geological repositories and get that off of people's mind. What do you think the psychology of this whole situation is in the public?
There's nobody that said no, that our idea is not viable and can't work. But what they're looking at right now is a real easy fix and a quick solution that just isn't there. And they have not worked and done the homework and did the things important to make this happen. It's sort of like they're ignoring it. It's like the trash that's building up in your backyard, but you haven't decided to clear it out yet. We are sort of got tired of that, and so we're trying this other approach. And I don't see any movement on the federal level, but states are really getting interested because they're having the power's a problem with them. Electricity is becoming an issue with them. The intermittent power that's on there now is causing them a lot of trouble to try to produce energy that way. And so the path they're on is just not working. So part of it is to give them a benefit that they could jump on to try to accept this, a way to educate their public. Once you get the governor and some of his supporters on, it makes it easier for the public to come along with it, because now they have a guy or a gal they trust that they can now listen to and sort of open their ears up on it a little bit. And in the long run, you're going to see, I think, the sort of a wave of acceptance. And then eventually you're going to have to educate the environmental people. They really like nuclear. The vast majority of environmental groups really like nuclear. And so but they don't quite understand it. So that's another aspect that we'll have to get on and provide education to. And politicians, in my experience, follow what they perceive to be the public perception, and actually kind of drive the public perception in a lot of ways. So if they're spouting negativity about it, the public's going to take that attitude. But if we can turn that tide a little bit, maybe one crack in the armor will make it happen. Now, understand, Canada is a much more accepting of nuclear power and nuclear reactors. So maybe we could take a lesson from how Canada deals with it and look at that down here. And there's a lot of ways to crack the code, but in my estimation, we're on a path now that's going to lead to a monopolistic control of energy. We all know that energy is the key to quality of life. In fact, they're marketing that to Africa, mostly through Russia, as a way to improve their quality of life there, which some countries have one hydroelectric dam to power their entire country down there. So they really have a long way to go. And there's a wide open market there. So as we march down this road of what do we do for future energy, I'm just a real proponent of competition. That's the way you drive lower prices. There's a way in this reactor business that you can have wide levels of competition for types of reactors that are built for different applications. If we figure a way to open up the distribution system to everybody, then we can really choose which power we want to buy, and that would sort of be the goal. But this could turn into something that really solves the energy problem, that really gets everybody to have affordable, available, and robust energy. And that's really what their goal is. And this is 100% clean energy. It's already exists. Donald Trump talked a lot about having a uranium supply because we only get 5% of our uranium from the United States for the current reactors. This is already a supply that's sitting here. It's already sitting on the sites. It's already available. It's 100% domestic production and exists throughout the world. So if we could start this here, there'd be a real export economy for it as well. So that's the vision, Al. And I think it's a matter of just talking to people and figuring out how to do it. Everybody I talk to about this really loves the idea. I think it's just a matter of having the conversation.
Yeah, it's basically the federal government placating everyone's fear. Instead of taking the bull by the horns and educating them to understand the realities of nuclear energy, nuclear waste, what can and cannot happen, what was supposed to happen at one time, I think would make a huge difference. Usually the anti-nuclear people, again, first thing, well, you don't know what to do with the waste. Can you imagine? Hey, we're going to recycle it. We're taking the wind out of their sails. What can we do with this and produce more energy yet? It's going to be the first place that goes with this, the first state, or it could be worldwide. We could actually have import, export of this, and it's not. People don't understand that the nuclear navy have now, since the 1950s, sailed throughout the high seas with nuclear energy powering their aircraft carriers, their battleships. And at the same time, they're like, well, not in my backyard. But they don't understand that certain places, they take off the old reactors and the old plutonium and used spent fuel, and it goes by rail all the way to Idaho. I was like, it's already happening, and it's happening very safely. It's even this proliferation. There are so many steps for anyone, a terrorist group, to get through this to make it happen, and it's even the wrong material. So it's like 40 years worth of misinformation, wrong information, a couple of sensational things that would not happen here.
I think the proliferation risk is definitely overstated. I think most states that want nuclear weapons have a path to getting them. Doing it through nuclear reactors is not the most efficient way to do that. You've seen Iran doing it through a different pathway. They made the uranium or the plutonium they needed, and this is what they're doing. It can be done. It doesn't enable groups to do this that wouldn't otherwise have the opportunity. So I think that's a bit of a red herring that's being put out there to try to slow it down, is mainly a red herring. The other anti-argument that I see a lot of is that, well, these new SMR reactors, these new next generation reactors are just paper reactors. They're going to be decades before they're ever built. It's too slow. We need things right now. I hear that a lot, but it doesn't mean it's not a good thing to pursue.
It's interesting, Al. This has plagued the nuclear industry forever. They create the fear of nuclear, then the government over-regulates the whole thing, causing it to cost a whole lot more money, and then they complain that it costs a whole lot more money. So if you wanted to stop cars from driving, all you'd have to do is reduce the legal limit to 10 miles an hour, and then put enough safety stuff on them that they'd weigh, 25,000 pounds and cost $150,000. You'd stop people from driving overnight. So the whole thing with nuclear is they're trying to stop it. There's entities that see that as a competition that are trying to stop it. And now we're in a situation where we weren't 40 years ago, where clean energy is very, very important. At least people say it is. So we're in an opportunity right now that is very unique in history, and we can take advantage of it. So I still think that there's a component of education. I think there's a component of a great deal of ignorance. And when you combine ignorance and fear, people just go off on their own tangent and think they know what they're talking about. And so we're trying to change that. We're trying to move into the next generation of what we can do. People don't realize that current nuclear power is the safest industrial business on the planet. The industrial safety record of nuclear power production is better than any other industrial process, let alone any other energy production process. And SMRs are even safer because they shut down themselves. If you walk away from them, they'll completely shut down without any meltdown or any kind of problem that could cause hurts to humans. So you see that the accidents have been well contained that have happened so far, and that's because the safety devices are so designed so well that even humans can mess it up and it still doesn't hurt people. It may destroy the reactor, but it doesn't hurt people.
Well, it sounds like you've got your work cut out for you. I'm hopeful that your work does bear fruit and we get to move forward on this, because I could definitely see, and a lot of people I know would agree, that having an active nuclear fuel recycling program would assuage a lot of the worry that people have with nuclear waste. So I think, and the fact that there's this big carrot that it's 30 times the energy that we've pulled out of the mines is just sitting there waiting to be used, it seems like a no-brainer in a lot of cases. So I appreciate your work and and I hope that you do find some success, and hopefully through our podcast and through other means that we do start to turn opinions around in this direction. So thanks very much, guys, for coming on the show. I really appreciate it.
Thank you.
Well, thanks for having us. This is a great opportunity, and we really appreciate it. I hope we can maybe come on sometime else and give you an update someday.
Yeah, that would be great. Let me know when we have our first consent state running.
That'll be big news.
Greatly appreciate it. Thank you.
If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/TheRationalView. Thanks for listening.